Hello, it's Miss Conley again.
And Miss Andrews.
Now we're going to look at number 3 and 4 from worksheet 2, also substitution problems. So we want to solve the system using the substitution method for number 3. Okay, so we notice our top equation says y equals 6 minus 2x. So we're going to take 6 minus 2x and substitute that in for the y into the second equation. Okay, so when we do that, we're going to get negative 6x plus 2 brackets 6 minus 2x is what we're substituting in for that y is equal to 2. Okay, so we have negative 6x. What are we to do with that 2, Miss Andrews?
So we need to distribute that into each piece inside. So we have a positive 2 that we're multiplying. We end up with plus 12 minus 4x equals 2. And then we can combine like terms. We have negative 6x and negative 4x. That gives us negative 10x plus 12 equals 2. So we want to subtract 12 from both sides, and we get negative 10x equals negative 10. And then when we divide both sides by negative 10, we can see that our result is x equals 1.
Positive 1.
A positive 1, exactly.
Okay. Now what? Are we done?
Well, we need to find our y value as well, so we can take this x and substitute it into either equation. The first one is already set up y equals, so it'd be a little easier for us. So we're going to rewrite it. Instead of putting x in, we'll put the value of 1.
Okay, again in the brackets there. So now we have y equals, remember we have to multiply before we can do this subtraction. So negative 2 times 1 is negative 2. And now we can do the subtraction. So 6 minus 2 gives us 4. Now are we done?
All right. Well, we want to put our solution in as an ordered pair because we're showing the point where these two lines intersect. So we have our solution, the x value first 1 and then the y value. And we can go through and check our work by plugging in the x and y values into both equations. And if both equations are true when we plug in the 1 and the 4 for x and y, then we know that we have a correct solution. So it doesn't matter which one we do first. We can just do the top equation, y equals 6 minus 2x. So our y is 4 equals 6 minus 2 times 1. So again, we have to do that multiplication first, 6 minus 2, and then we get 4 equals 4, and since that's a true statement, we know we're halfway there in our other half.
Alright, the second equation was negative 6x plus 2y equals 2. So to check that, again, we're going to substitute, negative 6x times 1, substitute the 1 in for the x, plus 2 times 4, that's our y value. We want to make sure that that's equal to 2. So, order of operations, we need to do the multiplication before that addition. So this negative 6 times 1 gives us negative 6, plus 2 times 4 is 8. Does that equal 2?
It does. We end up with a positive 2. 2 equals 2, a true statement. So since they're both true, then we know that we have our correct solution.
All right. Let's look at number 4.
Okay, make that big again. There we go.
Okay, so we have if y equals 2x plus 4 and 3y equals 18 minus 2x, solve the system using the substitution method. Now, the first thing I'm going to do is go ahead and write our second equation below the first equation. That's how we're used to seeing these problems. Now what?
Okay, well again we have a situation where we have a y equals, so we can take this value of y and substitute it in here where we see y, and then solve for our one variable. Let me get a pen again. Okay. So
Alright, and notice that's a 3y, so we have a 3 in front of it, and what are we substituting in for the y?
2x plus 4, and then close your brackets, equals 18 minus 2x.
Okay.
So we'll distribute our 3, and on one side we end up with 6x plus 12, and that is equal to 18 minus 2x. We want to move all of our x's onto one side of the equation, so we'll move it by having a plus 2x to both sides. and that shifts the values over. 8x plus 12 equals 18. Subtract 8 from both sides. Excuse me, subtract 12. I was looking at that 18.
Okay, so 8x is equal to 6. Divide by 8. Uh-oh. Alright, so that's a fraction. It's not going to be a whole number answer. That's okay. 6/8. I don't think we should leave it like that. What can we divide those both by?
They're both even numbers. We can reduce our fraction to divide both pieces by 2, and we get 3/4.
Alright.
But we still want to have our y value as well. So we have to plug in x into one of the equations. Again, if we pick that first one, it already says y equals. So we want y equals 2, open your bracket, 3/4 plus 4. Y equals...
Let's cancel. Divide those both by 2, so we can make this a 2. So that's 3/2 plus 4. We better get a common denominator. What's 4? What's the common denominator?
That would be 8/2.
Okay.
And we add those together, we get 11/2. And it's okay to leave it as an improper fraction. We have our two pieces there. And we again need to write our solution as our ordered pair. 3/4, 11/2. And
so what does that mean about these two lines?
That they don't intersect. If we were graphing this on our graph paper, they wouldn't be intersecting at one of our nice whole number grids, but they still intersect each other at just exactly one point.
Okay.
All right, so why don't you plug those solutions in and check your work.